Structured query language, better known as SQL, is a universal language for managing and manipulating data stored in relational databases. Whether you're querying a massive enterprise system or building the foundation for reports and dashboard, SQL is essential skill that bridges the raw data and real-world insight. In this course, we'll guide you the basics of writing simple select statements to more advanced techniques. You will learn how to explore data with confidence, extract what matters, and support analytics and business intelligence efforts at any scale. My name is Dhruv Singh, and I will be guiding you through learning journey of blending real-world experiences with clear hands-on instruction to help you master SQL efficiently and confidently. So, without a further ado, let's dive in and start speaking the language of data.
Now we'll start with the introduction of Microsoft SQL Server. We'll see everything around Microsoft SQL Server, the terminologies, the frequently asked questions, and how does the entire function work. In the coming PPT, we'll start with the popular use cases of data. Now you have to understand that in today's world, data is something that is one of the most important things. There are companies that are revolving around the data. There are companies that are working on the concepts of data sets. Take an example of Facebook, right? Now, what happens in the example of Facebook is that whenever we are browsing any sort of social media website, it is trying to understand our trends, pattern, our browsing history, how are we looking forward towards the product, everything in detail, we are trying to see that. Now, by our pattern of browsing, by our pattern of liking a product or liking a particular video, we are being suggested videos accordingly. Also, these e-commerce websites are practicing exchange of information. In this particular exchange of information, what is happening is, take an example of Facebook. Facebook is showing you Amazon ads, right? The particular items that you have dropped in the cart or the particular item you were browsing will be suggested over here as ads in Facebook, right? So there is also an exchange of information happening. They are collecting huge amount of data by our pattern of browsing, seeing this particular content, and they are trying to get the taste and liking of their particular customer. Now, in the same manner, Uber is collecting huge amount of data. During the peak hours, your ride prices go high. During normal hours, it's low. If there's a concert going on in the nearby areas, right, they'll try to allocate more taxis around that. So they are collecting this data and accordingly making this particular taxi services more efficient for the end user. Then we have Bank of America. Now, today's world, there are a lot of financial apps that have come up, right? You have a separate app for paying your credit card bills. You have a separate app for doing the share market, SIPs. Now, in this cases, the company or the bank's own inherent app are lacking a lot. Banks are collecting data from their customer and trying to make the experience as good as possible. So in such cases, Bank of America is collecting feedback from their existing customers, trying to understand their banking experience. All the banks are doing that. Every bank is taking feedback from their end users so that they can make their banking experience and their particular applications much more easier, so that the end user or the customer doesn't have to come to bank and is able to do 90% of his banking from the mobile phone or from his laptop accordingly. Same case, Amazon. Amazon is improving e-commerce experience, right? It is collecting your data. It is providing it to the multiple sort of social media websites where you're getting suggestions, where there is some sort of sales that they are able to spark. Because if I have something in mind and I change the app and I see it again on Instagram, I remember that I was trying to buy this thing on Amazon. At the same time, they're collecting your browsing experience. They are giving you notifications for any sort of discount on your product. If any product is in your wish list, they are providing you that also. Same in the case of Spotify, right? Spotify or any sort of music streaming platform is based on the part of knowing your likings and suggesting you the songs accordingly. That is how these engines work, right? The better suggestion you have, the more engagement they'll get. And with that engagement, they will either be able to sell you their particular subscription plan, or they'll be able to sell you their particular part of ads that are coming up in their particular free plan in Spotify. We also have Airbnb. Airbnb, what does it do? It will analyze our existing stays, right, or it will analyze the previous history stays and accordingly suggest us if there is any offer going on our liking or our taste preference sort of villas, right? If I'm searching for a particular location, the suggestion will keep on coming. Timely intervals, they'll be telling us about the offers and discount as per my liking or the taste or the particular location that I like to go. So these sort of use cases are only possible through huge amount of data collection from their particular end user or from different companies and putting it, churning it and getting the actual, you know, sales done. So if I am buying a product, from me buying a product to me paying for it, companies are putting a huge effort. So we have to understand that and you have to understand the thought process behind them because that is something that pushes a particular sales in today's world. There are no physical sales team, but the sales team is on your PC, they're on your particular phones, and they're collecting data from you and putting you into a scenario where you're buying product as per the liking, or if you even have a certain liking about that product.
Just a quick note, Analytics Vidhya has 100 plus free courses from beginner to advanced on topics like machine learning, generative AI, agents, etc. Complete with certification. Click the I button to explore now.
Now, going on further, you can see this is a common example, right? A product that I saw on Amazon is being displayed over here on my Facebook. So that is how this interdependency work. Now going on further, let us see into the SQL Server now. Now comes the question, what is SQL? SQL stands for Structured Query Language. In our particular tutorial, we have designed it for both professional and beginners. Structured query language is used to perform operations on records stored in databases such as updating records, inserting records, deleting them, creating and modifying databases, table, views, etc. SQL is not a database system, but it is a query language. In simple words, I say it's not a data repository. It is a way of hindering or it's a way of manipulating data. Structured query language was one of the first languages that was developed using which we could actually modify the data, make changes in the data, update the data, and insert the data. Also get data as per our requirement. Now, suppose you want to perform queries on SQL language on stored data and in database, you are required to install database management system in your system. For example, Oracle, MySQL. So these are different vendors that we have. Structured query language is the language. There are multiple vendors who have the systems installed in which you can run your structured query language. I have MySQL, Oracle, MongoDB, PostgreSQL, SQL Server is what we are learning. DB2 is there, and multiple other tools are there. We are going on further on the SQL part. If I break down this thing, the term stands for Structured Query Language. Structured Query Language is divided into multiple parts. First thing that we have is DDL. DDL stands for Data Definition Language, which is also termed as defining. You're defining this particular parts. So when we are creating a table, creating a database, it's a structured. So in the structured query language part, it is called a DDL command because I'm defining. So first we define, then we manipulate. So we create, we alter that existing created data, we truncate, we rename, we drop. These are all DDL commands. Now going on further, I have DML commands over here. Insert, update, and delete. I'm inserting records into a table. I'm updating that existing record and I'm deleting that record. So these are more part of manipulating the existing data. This is about creation and deletion of the data. This is about manipulating the existing data. Now going on further, we have data control language. Data control language is something that manages the control of a particular user. I can grant some permissions to the user. I can revoke that existing permission. That is your DCL. Next part that we have over here is transact control language. So the first thing that we have is if I run a query, I do a commit. If I want to roll back the entire transaction, I do a rollback. Now, when you are running a particular query, you can also put save point in that. Take an example, when you play a game, you can save it in the middle, right? When you resume the game, it starts from the same point. In the same manner, when I'm running a huge query and I can put save points in the middle point, till the time your query doesn't fail, it will have multiple save points in the middle. If I take an example, I have 20 lines of code, right? In those 20 line of code, I have put save point on every 5 line. If the code fails on the 17th line, I can go to the nearest save point, that is the 15th line. So that is how we can do that thing. Next thing stands for data query language. We have to query the data like you query a mine, right? Same way, data querying is done using select command where huge amount of databases are there and we catch up information or we do a select on that information using multiple where clauses. Now, once we have done this thing, this is the history and evolution of SQL. This is the history and evolution of SQL. Scientists who were working in IBM invented SQL in the year of 1970. So if I count from 1970, right, we are around 50 plus years, 55 plus years around over here, right? Donald D. Chamberlain and Raymond F. Boyce were the creators of SQL. Initially, it was termed as SQL, later conflicted with the term, like later changed to the term of SQL to resolve the naming conflict with an engineering firm in UK. You can call it any way. You can call it SQL, you call it SQL. At the end of the day, you should be good at query writing. That's the main important thing. Structured query language evolved over the years, expanding. Its functionality was declared by the American National Standard Institute, ANSI, as the de facto standard in 1986 to ensure portability across database. That was a big thing. In 1986, SQL was recognized as a de facto for data manipulation and portability across database, which means whatever data manipulation will happen, structured query language will be the standard for it. In 1987, ISO adopted SQL as a standard. SQL is standard to manage databases such as MySQL, Oracle, Microsoft SQL Server, etc. Current SQL standard is SQL 2019. Now comes the advantages of SQL. You can see there are multiple advantages that are coming up. Reduce data redundancy. Now, what does it mean? I'll take an example of Excel. I may update a record multiple times in Excel without knowing that it has already been inserted. But in SQL, I may have put a primary key on that ID, or maybe I kept that ID as unique. When I keep the ID as unique, what happens is if anybody tries to insert the value again, it will throw an error that this ID is already there. So there are multiple ways in which we can reduce data redundancy over here. What else can be done? Reduce errors and inconsistency. So we have multiple, like we have well-defined data types, we have well-defined structure, there's a proper query that we write. So errors, possibility of error is less. If I've defined, I've taken example in any data type, right? If I have defined it as text, it will not take an input as number. Or if I define anything as number, I cannot take the input as text. So that sort of rules that we have set up over here reduces the risk of errors and inconsistency. Greater data integrity and independence from application program. Data integrity is maintained because you have proper roles, you have proper security available. It is an independent program. It has its own database, it has its own language. So there is no dependency. That leads to more secured environment for the end user. Improve data access to users through host and query language. So you can access the data, you can run queries on that data set. Improve data security. You will have a password on the data set. You will have multiple sort of securities at different levels, which can help you secure your data. Reduce data entry, storage, and retrieval cost. That is the main essence of SQL. SQL was there so that I could load millions of records and extract values out of those millions of records. So you have to understand that this was designed for the purpose of efficiently performing load and extract. There are multiple sort of calculus theorems that are running at the backend which are making the engine even better with time. Faster query processing, large amount of data is retrieved quickly and efficiently. That is the strength of SQL. Well-defined standard, portable across multiple systems because it is a standard. There are systems will have SQL considered when they are designing a new tool. It is an interactive language. Whenever you write a query, it will give you results accordingly. SQL creates multiple views or virtual tables so data integrity can be maintained. Now, take an example. If I have an employee table in my organization and I want to do some manipulation on that table, if I change the pre-existing table, that will question the integrity. Also, understand one thing, it is very important data. I cannot play around with that data, right? So I'll create a virtual table or a view above it. That view will help us manipulate. So I will be able to do all my operations without affecting the original table. Even if I drop that view in future, even if I delete that table in future, right? Delete the view in future, then the original table will not get affected at all. So that is the advantage of creating views over here. Now, once we are clear with this thing, we'll go to the next part, features of SQL. I have high performance, high availability, scalable. So high performance, that is a strength. Availability, it is available on the server 24/7. It is scalable and flexible. You can write codes and make changes accordingly. Ease of development, you can learn the SQL query language and easily create codes on it. High security, security is something that is a strength. You can manage the access, you can manage the security over here. Open source, it is available free of cost. Anybody can download it and learn and start working on it. Management ease, because there are multiple sorts of available settings, you can manage the data set easily over here. Robust transaction support. Now, for any particular tool to be successful, how good is the support is a very important part, because this particular tool is available from a long period of time. Whatever mistakes you'll go through has been experienced by n number of people, and you will be able to find that in the forums available online. So you'll not be stuck with the problem, because this is not the first time that you're running into it. There are multiple peoples in the past who have gone through this problem, and they have shared their experience on the forums over here. Now, once we have understood the features of SQL, we'll go to the next part. Now, the things that come up over here are the databases and the types of databases that we have. Now, you have to understand there are multiple databases that we have around the organization or around the world. Data in general word is used to store financial, customer, health, any type of information that is available on the particular medium. Vast amount of such data for social media networks is stored in large cloud databases. So we have multiple side types of databases. There are cloud databases, graph databases. There are NoSQL databases. We have n number of sources. Relational database is also one of them. Currently, what we are seeing is the relational database. You can see multiple databases are there, right? We are seeing the relational database, which has derived its name from tables and join. It works on the concept of relationships and join. In the types of databases, most common everyday database for use by SQL Server language is relational database management. All popular databases are relational. So one of the most popular databases is RDBMS, or Relational Database Management System. These are the multiple vendors we have. We have Oracle, MySQL, IBM, SQLite, Sybase, PostgreSQL, Microsoft SQL Server. So these are the different vendors who are selling SQL. In general, these are the products that they have created for people to run SQL queries on them. The query that Microsoft SQL Server is created is called T-SQL. Again, it runs on the concept of SQL. The only difference is that a little bit changes because proprietary. So little bit changes they'll bring in the concept so that they can claim their proprietary rights on it. Now, types of databases, because we are talking about databases, we will talk about the present and the future. It is considered that NoSQL will be the database of the future. Why? Because it doesn't work on any sort of relational database. It's non-relational in conjunction to SQL. It doesn't have a predefined schema. When I say it doesn't have a predefined schema, it means that it works on a folder based approach. The way you have folders in your PC, in the same manner, it has folder inside it. It is very good for storing hierarchical data. The way in your PC you have folders, right? Inside a folder, you can have another folder, and that folder can have five more folders and keeps on going like that, right? So hierarchical information can be stored good. Also, because it has no fixed data type, it can be used to fetch or connect through multiple online data sources. See, if I define a table, it's a structured table, which means that if I've defined a column employee ID, employee name, salary, and age in it, I cannot expect anything else of the particular column except of the columns that are there. And also, I can even not bear if there is any data type change that is happening, because that has been structured or defined. When we define a NoSQL database, what happens is, like, it can expect a Word file, it can expect an image, it can expect a video, anything coming up, it can process that. So it is dynamic on that thing. It's horizontally scalable. Normally, SQL is based on ACID properties, which we'll discuss in the coming time. NoSQL is based on CAP theorem. And SQL is something that has excellent support available thanks to its age-old dataset and age-old existence. NoSQL still has to rely on community support only. So NoSQL has not still been able to crack multiple aspects, which it will crack in the coming future. Now, once we have got this thing, we have a data over here. You can see data is written. Data, if I say, is a book, right? And database is a library. So a book in a library, right? Database is the place you are storing it. Books. There could be multiple types of data set. You can have a magazine, you can have a financial data, you can have large folders, coffee tables, etc. Data format could be either numeric, alphanumeric, alphabetic, multiple data types could be there. SQL uses command to manipulate data in relational database. The SQL query is written in the program called Relational Database Management System. We'll talk about this in the coming time. What is an RDBMS? Now, after talking about data, we'll come to tables over here. In the table part, you can see this is my particular table. I have first name, I have last name, date of birth, and ID. First name is available over here, last name is available over here, date of birth and ID is available. Table name is personal information. Data resides in the table. Each cell contains the value, name, ID, surname, and date of birth. So these are the column headers that we have. These are the column headers or the columns that we have. First name is one column, last name is one column, date of birth is one column, ID is one column. This is one row. Alan Smith, 27/07/1990 is the date of birth, and this is his ID. So this is one row. Row are also called as tuples. So you can say we have 5 rows in the data. And how many columns? 4 columns over here. It's a combination of row and column. A table can have any number of rows, however, it has limited column depending on the context of the table. So this is very important. I could put million rows in that data set, no problem. But if I add one more column, that will hinder the structure. The structure is already defined of the table. It cannot be hindered. You have to command or you have to pass an alter command to first change the structure and then add values into it. So that is the structure of a table. It cannot have multiple columns until altered. Column headings are called attributes of the data. All the tables have constraint to maintain integrity. So we will be seeing constraint in the coming type and how do we maintain integrity on them. Now, once we are clear with this thing, we have a SQL syntax mentioned over here. Whenever you want to write a SQL query, you have to follow the SQL syntax. So over here, you can see when you want to do some operations in the data and database, then you must have to write the queries in predefined syntax of SQL. The syntax of structured query language is unique set of rules and guideline, which is not case sensitive. Though it is not case sensitive, but I prefer or normally people prefer to write the keywords like select, from, all these things in a particular uppercase so that the user or the readability becomes better in future. If any other developer comes after you, he'll be able to recognize that these are keywords. Following are some important rules. You can write the keywords of the SQL in both uppercase and lowercase, but writing the SQL keywords in uppercase improves the readability of the SQL query. SQL statement or syntax are dependent on text line. We can place a single statement or on multiple text lines. So I can write the entire, it's not dependent on text line. Normally, we can place a single statement on one or multiple text line. What does it mean? So if I write the entire statement in one line, right, it will still process it. But if I put in multiple lines, readability is better. That's the only thing. SQL statement depends on relational algebra and tuple calculation. I talked about this tuple relational calculus to get the result faster for us. Every time we run the query, it collects that cache and makes that particular memory faster. SQL statement tells the database what operation you want to perform on the structured data and what information would you like to access from that database. So that is an important part over here. Now, once you are clear with this thing, we'll go to the next part. This is a basic select command that has been written. Simple example of a SQL statement that we have in front of us. We have written select column name from table name. Each SQL statement begins with any of the SQL keywords and ends with a semicolon. So you can see keywords are written in caps. You have select and from over here. Semicolon marks the ending of the SQL statement. The semicolon is used in the SQL for separating multiple SQL statements which are going to be executed in the same call. In the SQL part, we will be seeing semicolon at the end of each SQL query statement. So what the tutorial that we are going to run, we'll have semicolon written. Semicolon is something that if I have multiple queries written and I want to run them at once, it will make sure that each and every query is separated from another. Now, once you are clear with this thing, we have SQL commands, basic SQL commands that we use on a day-to-day basis. We have create, select, drop, insert, update, grant, and revoke. These are something that you'll come across if you're studying SQL and you're working on them. These are one of the most commonly used commands that we have that are used to perform operations, manipulate the data. You can see select is to fetch the data, insert is to update the existing data, and delete is to remove the data. Now, this is something that will tell you about the architecture of SQL. Whenever I write a SQL query, there is a parser and optimizer. Parser will check the syntax. It will call traffic cop, identify query type, commands, processor if needed, break query into tokens. Optimizer is more like a planner. It will generate a plan. It will tell you the uses of database statistic, query cost, calculation, and choose the best plan for that particular query to run. Then we have the database management system engine over here. Now, once your query has been processed, it has the best plan of action, it will take you towards the file manager or transaction manager, which will take you to the physical file that is there in the database from which it will interact and fetch the information that is passed in the query. Execute will be handling the execute query part. So when I click on execute, it will run the execute accordingly. Normally, when you write a query, these are the types of modules it runs through. It will go to a parser and optimizer. Parser will try to analyze the entire query, see for any sort of errors or something like that. Optimizer will find the best possible plan of action. Then we have the file manager and transaction manager, which will help you connect with the database that you're looking for. And then we'll be executing the query. Now, once we are clear with the architecture over here, we'll go to the next part. Why SQL? Why should we learn SQL today? Nowadays, SQL is widely used in data science for analytics. Following are the reasons that you should clear out why you should be learning SQL, why you should be learning SQL. The basic use of SQL for data professional and SQL user is to insert, update, and delete data from relational database. SQL allows the data professionals and the users to retrieve data. SQL allows the data professional and users to retrieve the data from relational database management system. It also helps them to describe the structured data. It allows SQL. So if I say it in simple word, if you ask me why should I learn SQL, just for the sake of understanding how does a database work, just to understand the groundwork over here, the base of database management system, SQL is important. It is important to learn advanced languages in future. It helps in describing the structured data. It allows users to create, drop, and manipulate database and its table. It also allows in creating view, stored procedure. It allows them to define data, modify it, and store that data in relational database. It allows users to set the permissions or constraint on table, column, views, and stored procedure. Once we are clear with why we should be learning SQL, we'll go to the next part. SQL in real time, healthcare organizations, your hospital are managing their inventory records, they're managing their patient records, hospital information, available rooms, what type of cases they are handling, what number of doctors they have, what types of patient they are having, which doctor is looking after of which patient, all these details. Education, what are the most common programs on which the students have been enrolled, how many trainers do we have, how many trainers do we have per student, how many students do we have, what are their fee structure, how many have their fee pending, how many of them have bought the books from the organization, all these details, how many of them have borrowed the books from their library. So these sort of informations. Then we have our particular retail sector, customer acquisition, customer retention, buying habits of the customer, offers and discount going on a particular store, telling that customer, maintaining their particular customer records. Financial sector is vastly dependent on SQL. In today's world, even if you buy an SIP, you see a 5 years performance of that SIP. That is only possible with the data collected for that particular SIP. So financial data study, Understanding of market, understanding of different sort of share market is heavily dependent on this factor. Now, this is very important. SQL Server, if I say I have a database engine, that is my data storage, and I have a management studio. You need to have a management studio. A management studio is the interface which will help you process the information. A user interface for interacting with data and database. Database engine is the core of service for storing, processing, and securing the data. The database engine and management studio can be on the same computer but different, like you could have it on the same computer or on different computers. You can have it. So in a normal company organization, server or database engine is at the center or in the server room, right? Everybody in the organization, 20, 50 machines are kept, and people interact with that server, fetch information on it, and update information on it. From the management studio, you can connect to a local database engine or database engine located in the network. Now, once we are clear with this thing, so management studio will be the place. SQL Server Management Studio or SSMS will be the place where I'll write the query, and that query will go interact with the database engine and get us the information. You can see this is your SQL Server Management Studio. This is the place where you have the databases. These are my databases. This is how I write a new query on my SSMS. This is the place to write query. This is where the result will come up. You can see result is coming up. Query is written over here. Now, once we are clear with this thing, let us see the data types that we have in SQL. SQL data types, the type that is representing the nature of the data that is coming up. If I have my name written, it will be of varchar or string data type, which defines that the nature is in alphabetics or it is in the string format. If I have my age, it will be in int because it is a number format. So for example, in a particular column of a table, if we want to store a string type data, then we have to declare string data type of its column. So you have to tell what is the data type that you want to store. Data types are mainly classified into three categories for every database. First one is string data type, second one is numeric data type, and then we have date and time data type. Now going on further, these are the data types that we have for string. We have char and varchar is the most commonly used data type that we have. Char is a fixed width character data type. It can size up to 8,000 characters, normally used to store characters. Varchar is a variable width. It can store up to 8,000 characters. Most of the use cases are almost done by varchar. Then I have varchar max. These are all dependent on the number of characters that they can hold. You can see these are the differentiating factors. Variable width character data type, it can size up to these many numbers. You can see 10737411824 characters. Text is a variable width string data type. It can size up to 2 GB of text data. Nchar is a Unicode data type. It can size up to 4,000 characters. Nvarchar is a Unicode string data type. It can go up to 4,000 characters. Ntext is a Unicode string data type which can go up to 2 GB of text data. Binary N is a fixed string data type that can go up to 8,000 bytes. It is a variable, so var binary is a variable binary string data type that can size up to 8,000 bytes. Image is a variable with binary string data type that can go up to 2 GB. So these are the different data types that we have in string. Now in the same manner, I have date and time data types. So first one is date time. It is used for a specific date and time combination. It supports from the range of 1st Jan 1753 to 31st 999 with an accuracy of 3.33 millisecond. This accuracy will keep on increasing. Date time 2 is used to specify date and time combination. It supports from January 1 00012 to December 31st 4 times 9 with the accuracy better 100 nanoseconds. Date is used to store date only. It supports from January 00012 to December 31 999. Time, it stores only time with the accuracy of 100 nanoseconds. Timestamp. Now timestamp is a little different. It doesn't work on the normal clock or the watch that you follow. It works on the computer's clock. Computer has its own timestamp that it stores, and it is used for the file storage also. So normally when you sort a file on the basis of date, it is not the date and time, it is the timestamp. It will give a unique code for all the files that it is storing, and that will act as a time factor over here. That timestamp is normally the timestamp that we have over here. Now, once we have done this thing, these are the numeric data types that we have. I have bit. It is an integer that can be used for 0, 1, or null. Tiny int that goes from 0 to 255. Small int that goes from minus 32,768 to plus 32,767. Int is the data type that is most commonly used over here, goes from minus 21474836482 to plus 21474836447. Big Ant has a different series. You can see it's a big series. Float again goes from minus. It is specified floating precision number data. Their n parameter indicates whether the field is for 4 or 8 byte. Default value is n is 53. Real is floating precision data from this particular point to this particular point. Money is a specified data type for storing money. You can see the range over here. So you have a special data type for money also. Now the next thing that we have over here is SQL operator. SQL operators are normal terms, characters that are called operators which are used with the where clause. There are unary operators, so that have one value, and there are two operands also in that are binary operators. We'll see them. So first we have over here, this is called as exponential of our operator for power. Then we have the plus minus, that is identity and negation operator. Then we have multiplication and division operator. Then we have addition, subtraction, and this is a string concatenation operator over here. We have a is equal to, not equal to, less than, greater than, less than equal to, greater than equal to. Is null is to check the null values. Like is to check as per. So if the customer name is like Akash, Dhruv, that is like when I have to give multiple outputs. Between is used to get the values between a string, between a range. In is used to get output in a particular number or in a particular name. Not is a logical operator, not equal to. And or single and is used for conjunction operator or is used for inclusion operator. So and is used for a condition where customer name is equal to Raj and his age is greater than 18. Both the conditions have to be true. Customer name is equal to Raj or greater than 18. Age is greater than 18. Either of the conditions have to be true. So that is how it works. I know the introduction was a little overwhelming, but it is very important for you to know the basics before jumping on to the actual hands-on. So now we'll go to the complete hands-on. Thank you. Now we'll start with writing some queries on SQL. In order to write a query, I'll click on New Query at the top. So when we click on the New Query, I'll get an area where I can write my queries. Now this is a SQL Server Management Studio where you normally write the queries. So in order to create a table over here, take an example. First, we have to create a database. So create is a keyword. So I'll write it in caps. I'll say create database and I'll say that the database name is DB. When I execute this query, a database will be created. If you want to check, you can check the databases over here at the left hand side. You can see DB name database has been created. Now, once you have created the database, you have to use that database. You have to use that particular database. So I'll say use DB. This means that I'm using this database for creating tables in future. Tables will be saved inside this database. So I'll execute this statement. You can see this database is showing up. I can click on the use option by clicking on the options at the top from the graphical user interface also. Now, once I'm using the database, if there is a need to drop the database, I'll say drop database DB. When I execute this query, you can drop this particular database. Because currently we are using database, I can drop another one. I'll create a DB1. I'll create this database over here. Click on execute. Not use DB1 this time. I'll drop the database DB1. When I drop this particular database, it will be deleted. Now, once we have seen the drop command over here, what next? Now we have created the database. We have deleted the database. I'll create a table over here. So I'll say create table. We'll give the table name over here. I'll name it as EMP. Now, when you're creating the table, you have to define the columns inside it. I'll define the columns in this type. So I'll say I have an EMP ID, which is of integer data type, comma, I have an EMP name over here. Employee name can be stored in varchar data type. Because it's a variable length, you can define the length inside it. So we have the employee name varchar. Then I can have is age. So I'll say emp age, and I'll keep it an int data type. This is a structured query language. When you're creating the table, at that time, you're defining the structure over here. So we have the ID, we have the name, we have the age. We'll put the salary of that person. Salary, I'll put it up in money data type. Once I'm done inserting the records, I'll put a semicolon over here. So we are creating a table in the name of EMP. Employee ID is there, name is there, age is there, salary is there. When I execute this particular query, what we'll get over here is the employee table created. If I want to check the employee table, I'll pass a select command over here, select star from EMP. When I execute this particular query, we'll get all the columns inside it. I have employee ID, name, age, and salary. This is your employee table that we have. If by any chance I want to insert values inside it, so we'll say insert into EMP. Now after insert, we have to tell the columns that we have inside the table. So I'll say EMP ID, we'll say EMP name. You can see all the column suggestions are coming. Age, that is EMP age, if I'm not wrong. Yeah, then we have the salary over here. So I have the employee ID, employee name, age, and salary. We are inserting into the table. After putting this part, right, you have to write over here values. Values mark that you're putting the values now. Now, after that, you start putting the values. So employee ID is 1001, name is Ram, age could be 25 over here, and salary could be 25,000. Now, once we are done with this thing, I'll put a semicolon over here. This means that I'm done with inserting and I'll execute this query. When we execute, you can see one row got affected. If I do a select star from EMP and execute this query, I'll get the employee ID, name, age, and salary over here. So that is how you create a database. You use a database, you create a table inside it, you select from that table, and you insert values into it. If by any chance I want a certain column only, so take an example, I need the name of that person and his salary. So I'll say select EMP ID, comma, EMP name from EMP table. This way I'll get the employee ID and name only. So when I execute the statement, we are getting only values. Star over here denotes all the values. If you want a certain value, then you can do that. What else can we do over here? If I want to drop the table, I'll say drop table EMP. When you execute this query, this table will be deleted over here. So these are some basic commands to create database, update it, select values from it, and drop that database. Now I'll open a sheet to explain you some major concepts that are a little basic and required for the first session. For this one, I'm creating a database. I'll not create the database, I'll use the existing one only. Already we have done that. I'll create a table over here called EMP. We have already dropped that table. So if you want to check, you can check over here. If you open the DB database and you open the tables inside it from the left hand side, you will see that no major tables will show up because it's an empty part. Now I'll create a table over here named EMP. When I'm creating the table, I'm giving the column as primary key. Now it is very important for you to understand what is primary key. Primary key is one of the most important columns in a table. It is the recognition column in a table. So for customer table, customer ID is a primary key. For orders table, order ID can be the primary key. For product table, product ID can be the primary key. Normally, product ID or customer ID are unique, which means they are not repeating. For one particular product, you will have only one particular product ID. For one customer, you will have only one customer ID. So in that case, if I'm defining anything as a primary key, it means that it is unique, which means it will not repeat in the data. If you try to pass repeated values in that particular part, it will throw an error. These are called as constraint. I have defined this column name, I've defined the like data type of it, and I'm then telling primary key, which is the constraint over this particular column, that this is a primary key column. You cannot pass repeated values. Also, it is of high importance. So when I create this table EMP over here, you can see this table has been created. If I do a select from EMP name, salary, and EMP, you will get nothing. Currently, the values have not been inserted over here. I'll start inserting some values. I'll insert into EMP. I'll mention the structure, that the structure is employee ID, name, and salary. You could see over here we are passing the values. I'll pass these values over here. When I execute, you can see 4 rows got affected. When I do a select star from EMP, I'll get 4 values over here: 1003, 1004, 1005, 1010. Now try to understand this thing. If by any chance in future, if I'm inserting someone's name, take an example. We are inserting a name over here, Dhanush Raj. His salary is 80,000, and we have inserted him with the same employee ID by mistake. If we try to do this thing, it is saying violation of primary key constraint. You cannot have the same duplicate keys of these values. So you have to change the value over here, maybe keep it as 1019, and then try to insert the value. When you try to do that, it will go in. Now, when you do a select star from EMP, you will get all the values over here. This is basic insert that we have done and explained you the constraint primary key. Now, going on further. Now, this is a common question. What is the difference between unique key and primary key? You have to understand that there could be multiple unique key in a table, but one primary key. Also, a primary key is unique by default, but unique key is not primary key. If I take an example of bank, I can have a unique customer relation number, CRN, but my recognition will be by my account number. So that is the difference. Account number is my primary key. CRN is a unique key. Now going on further over here, I am going a little advanced on this thing. I'm creating a table employee. Rather than putting employee ID 11 increment, I'm putting it as a constraint over here, identity. In this identity constraint, I'm saying that employee ID is of integer data type. It is starting from 1000 and it is incrementing 11 value at a time. At the same time, I'm defining it as a primary key, which means repetition will not happen. Employee name is varchar and defined as the constraint of not null. When I define anything as not null, it means null values will not pass up over here. We have salary over here, which is of money data type, and age over here of integer data type. When I execute the statement, you can see employee table has been created. I'm not dropping the table. We are doing an insert. When I'm doing an insert in the employee table, I've mentioned over here employee name, salary, age. So name is Daman. You can observe one thing, that in the employee table, how many columns are there? 1, 2, 3, 4. When I'm inserting, I'm putting only 3 values over here. Why? Because ID is an auto increment value. You don't need to manually pass that. Only name, salary, and age is what you're supposed to pass. So when I do a select star from employee, you can see all the values have been inserted. When you insert the values, all the values get inserted. And when you do a select star, you can see Daman's record is coming with employee name, salary, and age. I'm inserting some more values. See, if I want to do a multiple insert after the values part, rather than putting semicolon, I put a comma over here. This way I can do a multiple insert. I'll do an insert into employee. These are some names that we have got. We have got 6 rows got affected. Now I want to show you also the employee names, not null constraint. Null means in SQL, you cannot pass anything as blank. You have to pass a null value if you're not very sure about the value. So if I pass a null over here, salary I know is 85, age is 39. So when I execute this part, what we'll get over here? Cannot insert null values into employee name. So you cannot insert null values into it. Again, if I pass a normal name over here, in this case, I'll pass a Dhruv, it will take without any problem. Now, when you do a select star from employee, you will observe that all the employee IDs are incrementing one value at a time because of the auto increment constraint that we have over here called as identity. Not null specifically means that you cannot have null values. Primary key will be followed because auto increment is happening. There is no case anybody will able to input any value forcefully in it. Now this was your identity and not null constraint. Now we'll go to the next part. I'm doing some mix over here on the first session just to give an idea of multiple concept. Then we'll go concept wise in things. Up over here, I'm doing a select star from employee. I'm saying where employee name like a percentage. When I mention a percentage, it means that the name of that particular employee is starting with A. So it will give me all the employee name that is starting from A. Over here, you can see April starting from A. So I'm saying select star from employee. where employee name like is something which is given when we are expecting multiple inputs or outputs. So when I execute this particular query, I'll get April over here. If I insert some other values over here, take an example over here, Ajay, 35,029. When I execute this query, one row got affected. When I do a select star from employee where employee name starts with A, you'll get two values now, April and Ajay. So that is how you can use like to get the value starting from A. If the percentage sign would have placed below, then the ending with A would have also come up. Now I'm doing a basic update over here. I'm saying update employee table, set age as 25, where employee name like A percentage. So two people have A starting as their name. We'll set their age as 25. So when I execute this update command, now there are two differences over here. Update and alter are two different things. Update is not changing the structure of the table, it is changing the existing row. So that is the reason it is an update command. Alter, on the other hand, changes the structure of the table whenever you have to add a new column, whenever you have to remove an existing column or change the constraint. In that cases, you have to pass an alter command. So when I execute this statement, it will give you an update over here. When you do a select star from employee, you will see that two people were there, right? From the name A, April, age is coming as 25. Ajay's age is coming as 25. So this was a single update that we did. So for single update, set is something that is important. Update command is important. Update, you have to tell the table name, what you want to set, and where do you want to set. I'm doing a multiple set over here. Over here, I'm saying update employee table, set age as 55, salary as 1 lakh, where employee ID is 1005. So employee ID 1005 is for Feroz. I'm saying that put his age as 55 and salary as 1 lakh. Currently age is 35 and salary is 45,000. When I execute this particular query, you will get one row got affected, right? When I do a select star from employee, you'll get over here Feroz details, employee ID, Feroz, salary is 1 lakh and age is 55. So this way you can check this particular part. So this was an update using two sets over here. We are setting up two values. You can do a multiple set also. Now I'm changing the structure of the table. For this, I'm passing an alter command. I'm saying alter table employee add status varchar. So we are adding a column called status, which is of varchar data type. By default, the value inside the status column will be working with values. When I execute this statement, you'll see employee table got updated. When I do a select star, why am I passing an alter command? Because I'm changing the structure. I'm adding a new column called as status, which is of data type text. Default means the value will be default working will be there in every value. With values means default working. See, whenever you were inserting, you were putting values over here. Na? So same way I put over here with values. So default will come with values, and over here you will see working will be written in all the rows over here. This is what this is the alter command to add a column with pre-existing values. Now, once you are clear with this thing, we have another alter command. In this alter command, I'm adding in the table employees a column called detail, which is of null. So which is of integer data type, and the values that we have passed in detail is null. When I execute this query, a column detail will be added with only null values of data type integer. So you can see data type integer details is coming up over here. I'll do a drop later. First I'll update. So it is saying update employee, set details as 12, where employee name is equal to June. So when I execute this query, you will see only June record will be updated. To get the fetch the details over here, I'll do a basic select star from employee where employee name is equal to June. So when I execute this query, you'll see detail will come as 12 over here. If you do a basic select star, all the other values will be null, only employee name June will be updated. So this is how you do an update over here. After updating this thing, we are altering the table again, and I'm saying that I want to remove this detail column. So I'm saying alter table employee, drop column details. When I drop the column detail over here, what will happen? this will be removed. You can see this particular part has been removed over here. Dropping of constraint we'll see in the coming part, don't worry. Abhi, for now it will be too much. Now you can see over here we have dropped column detail. If I do a basic select star over here, you will see there will be no column in the name of details. So this is how you can delete columns in your particular data set. Now if you want to drop the entire table, you can drop the table employee. If you want to delete a certain record, see, drop is used to alter a column. If I want to delete a column, then I'll use drop. But if I want to delete a row, in that case, we will use delete command. Over here, if you see delete from employee, where emp name is equal to June. So from the employee table, it will delete that particular row where employee name is equal to June. When I execute this particular row, when I execute this statement, you can see one row got affected. When I do a select star, you will see there is no row in the name of June. That is how this particular thing works. Same way you can delete from employees where employee ID is 1002. So April will be removed. When I execute this query, it is gone. If I do a basic select star over here, you'll see April has been removed over here. Now after this thing, I'm doing a delete top 2. Now top 2 doesn't mean that it will find the top 2 values and delete. No. From the top, it will delete the 1000 and 1001 row. I mentioned a where command over here also, where salary is greater than 20,000, which is obviously greater than 20,000. So when I execute this statement, 1 and 2 will go. If you want to do, I'll do a select star from employee. You can see 1000 and 1002 has gone. Delete top 50%. Now, currently I have around 5 values. I'm saying top 50% where salary is greater than 20,000. If you want, you can increase this width also, that I can make it up to 45,000. When I execute this query, top 50% will be removed. If I do a select star from employee, we have 3 values coming up. So this is the 3 values which have values greater than 45,000. After the top 50%, we have select star, a basic select star, which will give you the values. So this was some hands-on idea on the select command, on the where command, update, delete, alter, some idea about constraints. We will be going topic wise in the coming parts. I hope you get an idea of this thing. We'll go to the next part. Now we'll be seeing the different type of constraints in SQL. We'll be seeing that in detail and we'll try to understand the constraints. I'm creating a table called person. We have ID, which is of not null data type. We have the last name, that is of varchar data type, that is text, again not null. First name, data type varchar, not null, which means null values cannot go into them. So first we'll see not null over here. I'll create this table person. After creating this table person, you can see ID, last name, first name, all are of not null data type. You cannot leave null values. When I insert into person table over here, you can see ID, last name, and first name is there. I'm deliberately passing a null value on the first name. When I execute this query, it is saying cannot insert null value in first name, which means it cannot handle null values. Then we'll pass the value over here. When I insert into the table, it will give you the values as it is. Now, once we have understood the not null constraint, I'll create another table in the name of person this time. That was a person with an S just for that part. I'll create a table called person, which is ID is not null and unique. Mind you, I'm not defined the ID as a primary key. It's not one of the most significant column right now. It is unique. Unique means it cannot handle repeated values. Last name is not null. First name is varchar and age is integer. When I execute this particular query, you can see command completed successfully. When I insert values inside it, you can see this value has been inserted. Unique also behaves in a certain manner. When I try to repeat this particular command, you will see unique key constraint cannot duplicate objects. So duplicate key is there, that is 101, which means this 101 is duplicated. If you put it as 103 this time and you make it as Raj. Now when I execute this particular part, it will take it without any problem. So unique is simple thing that will not take duplicates values in it. Again, I'm creating a table over here, a person one this time, which is of ID not null. I'll say primary key is what has been defined over here. Null values cannot be defined. Last name has been defined as varchar not null. When I execute this particular query, I have told you in the previous session also that primary key is of far more importance than unique key, and it will follow the attributes of unique only, that you cannot pass repeated values in it. So this is how, if you try to pass, so take an example, I'll just try to insert some values inside it. So I'll say insert into table person one this time. This is the person one table. I'll copy this command over here. Insert into table person one, ID, last name, first name, age. Values are mentioned over here. You can see that. Now, when I insert over here, you can see the IDs are coming up. I'll execute this query, no problem. But if I try to execute this query again the primary key constraint violation will happen. It cannot insert duplicate values in it. So this is similar to unique key. Don't get confused. I've explained that in the previous session. Now over here, I have created a table called person12. ID is not null, last name is there, first name is there, age is there. When I execute this particular query, you will see person12 is created, right? Up over here in the table person12, I'm adding a constraint called pk_person. What is happening is we are altering this table. On the particular ID column, there was no primary constraint that was passed. So now we are learning how to alter the table and add a primary key constraint over here. So I'm saying alter table person12, add constraint pk_person. You can see pk underscore p and pk underscore person, and we have a primary key over here, and I mentioned ID over here. So we are putting a primary key on ID and the name of this constraint. You have to always name a constraint when you're adding it. So this way, what happens in future, if you want to drop it, you can drop it by the name. So when I alter the table person12 and add a constraint, see, I'll show you when you open the tables over here in DB, just refresh it quickly and then open the tables. You can see all the tables are showing up. Person12 is over here. Inside person12, if you open the columns, right, you can see ID is defined over here as not null. There is no key that is associated right now. If you open it is blank. When I execute this query, you will see that when I execute this thing and refresh this table, now when you open the column, ID has a primary key constraint over here. You can see in the keys also it is showing pk_person is the name of that constraint. Now this will help me drop also in the future. So we'll see the drop also later on. Over here, if you see, I'm creating a table that is order 1, 2. Order ID is not null, primary key. Order ID is not null. This is not of much importance. We'll go to the next part. Now over here, you can see over here we have a create command, right? I'm creating a table of person. In the person table, I'm defining ID as not null. First name has been defined. Varchar has been defined for the first name and last name, right? First name and last name. Last name has been defined as not null. ID has been defined as not null. But the most important thing over here is adding a check constraint over here. I'm putting a check constraint while the creation of this particular column. I'm saying age is of integer data type and it has a check constraint which says age should always be greater than 18, greater than and equal to 18. When I create this table person, already this table name is there. So I'll just drop this table name, drop table persons, dropped. Now I'll create this table over here, no problem. Now in this particular table, I'm saying that ID is last name, ID, last name, first name and age I'm putting up, right? When I execute this query with ages greater than 18, it will take it without any problem. But if I execute with the age less than 18, maybe 12 this time, 102, and I execute this particular part, you will see it is conflicting with the check key constraint. Age has to be greater than 18, but it is coming below that. If I pass the same thing as 18 over here, the values will be inserted without any problem. So that is how you make this thing work. Now, in the check key constraint, we had put it on the column itself. Now I'm creating a separate constraint over here. So I'm creating a table called person12. In person12 over here, what I'm doing is I'm saying that ID is not null, last name is varchar, not null. We have first name, age, and city defined separately. I'm creating a constraint called check person1. The constraint work is to check whether the age is greater than 18 and city is San Francisco. When I execute this particular statement, I'll just change the name. Person12 is already there, right? I'll drop the table in the name of person. We'll name it as only person over here. Execute this query. When I execute this particular query, the table has been created. I'm saying that in the person table, ID, last name, age, and city is mentioned. If by any chance you don't follow any constraint, it will not be able to execute the value. So if I pass a 12 over here, make it as Santosh. When I execute this query, it will say that check constraint conflict because the age is less than 18. So if you put the age as 18, it will take it up without any problem. So this is how you can put the check constraint as separate value also. There's one more constraint. We are creating a table. This is called as default constraint. I'm creating a table person over here. I'll drop the person again from the top. Over here, if you see, when I execute this statement, so what they are saying is create a table person. ID is not null, last name is there, first name is there, age is there, city is varchar. By default, the name is San Francisco. So this is something that you'll not be able, you'll not require to insert. So if you see over here, I'll take the person, ID, last name, first name, age, and city. When you execute this thing, if I insert into the table, you can see there's some issue coming up. 4 rows got affected. So 4 values have been inserted. So this is how you can create this thing. We have also seen the alter table with default working over there. So alter table person 1 to s, add status varchar. In that particular table only, you can add status as working default with values. Yes, this we have seen in the previous query only. So when we add this thing over here by default into the table, what happens? You'll see working will come up over here in every row. Identity was a constraint that we have seen over here. We are creating a table over here called as person 13, ID, identity key. Identity key means that you don't need to insert the values one by one. It will automatically take the values. So when I insert this thing, you'll see it will automatically take that value. If you insert more values in future, that also will be compensated. So if you do a select star from person 1, 3, this is how it will take it. So we'll quickly do that, then go to the next part. So in the person 1, 2 table, I had added a constraint as primary key. If I want to drop that constraint, I can do a alter table command, employee, drop constraint. So this is pk person. I'll put it over here, pk person, pk underscore person. When I execute this query, this particular command will be executed. There's one thing I have by mistake mentioned employee table over here. It will be person 1, 2. So this command has been dropped. The pk person has been removed. If you want to check, you can refresh this thing. You will see that in the column there will be no keys associated. So that is how this thing works. Now we'll go to the next part. We'll look into set operators. I'll open this thing. Set operators are of different types. We have union, union all, intersect, except. We'll see the working over here. I'm creating a table called exemp, ex employee. In this table, I am putting employee ID, name, varchar, department ID, and integer department ID for integer, and name for varchar. When I execute this statement, I'll get exemp. In the similar manner, we are creating a table emp, which has employee ID, name, department ID, everything mentioned. I'll execute that too. Emp is already there in the database. We'll quickly drop this table. I'll execute this query, dropped. Now we are creating a table over here called emp. In the EMP table, I'm putting some records, employee ID, name, and department ID. So we have these many employees that we are executing. Same way I'll insert it into EXEMP. Now, if you observe EMP and EXEMP, both have Ram and Harry in it. Hari in it. So you'll see Harry over here. So in the XEMP, right, we have Harry, Abish, Shlok, Harman, David. Over here, if you see, we have Ram, Abraham, Sham, Hari, Dev, Richard, and Himesh. I don't think so. There are some matching values. So we'll do one thing. I'll insert some more values over here. I'll put one over here as Ram over that table to match the values. And I'll put Harry over there. We are doing it deliberately to create this scenario. So I'll put Harry over here. Now we'll quickly do drop table exemp. When I execute this query, dropped the table exemp, and I'll drop the table emp also over here. I'll create this table exemp, and I'll create this table emp over here. We'll insert some values. So we have executed the values added. Just a second. Let me just check what are the tables that got created. Is EMP created? Yes. EXEMP created? Yes. So I'll insert values in EMP. I have employee ID. So in the EMP table, we have name and we have department ID. So I'm putting the names over here. When I execute this particular query, 9 rows got inserted in the EMP. I'll insert values in EXEMP also in the similar manner. 6 rows got inserted. Now first I'm doing a union. We had deliberately know that RAM is there in the EXEMP table. RAM is there in the EMP table also. Harry is there in the EMP table and Harry is there in the EXEMP table also. When I do a union will give a union between the two tables without any repetition of Ram and Harry. So you'll see Ram is coming once over here, Harry is coming once over here. Both the tables have been combined together, but the repetition will not come up. So union is a set operator that combines two tables together without any repetition. On the other hand, if I do a union all, it will give a combination of both the tables. It will append both the tables together, but repetition will be there. Ram and Harry is repeating over here. You can see Harry is repeating over here. Ram is repeating over here. So union will remove the repeated values. Union all will keep the repeated values. In the similar manner, I have a union all again. I'm doing a order by 3. Simply order by 3 means it will order on the third column over here. So when I do a union all and do a order by 3, you will get the values sorted in a department ID manner. You can define the order also. If you say that you want it in DSC, that is descending order, it will come in descending order over here. ASC is ascending order. You can define over here ASC. When you execute this thing, you'll get it in ascending order. There's also one more thing over here called intersect. We are saying select employee ID, name, department ID from EMP, intersect it with the employee ID, name, department ID from the EMP table and order by 1. The name over here suggests intersect will find the common column between the two tables. So intersect is used to find the common columns between the two values. In the same manner, I have except. Except will be like select employee ID, name, department ID from EMP, except employee ID, name from the EXEMP. So everything from the EMP table will come except the matching values Harry and Ram. If you see the EMP table, how many records are there? If you do a select from the EMP table, you have 9 records over there. But when you run an except over there, it will return 7 records. You can see 9 records are doing in a simple select. When I do a accept, it will show you 7 records over here. This is how except works over here. We'll keep it till here for the set operators. Now we'll see some SQL applications on string. So we'll start with the first statement. There is a statement called replace. In replace, I'm putting SQL tutorial over here. Wherever T is coming, I'm replacing it with M. When I execute this particular query, it will replace the T coming up in this particular SQL tutorial with M. So SQL tutorial, I mentioned the string over here. I mentioned the value that has to be replaced by the value that it want to be replaced. Same way we have data length over here. Data length in general, when I execute this query, take an example, is giving 11 as an answer. There is a length function also, data length also. I'll tell you the difference between them. So in data length, if you count this thing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Data length is considering the space also over here. If you leave a space at the end of the text, data length will return 12 over here. LEN will not consider space. We'll see that in the coming part. So over here, after the data length, we have a character index function. Character index will find the position of the text that you have mentioned. So I've mentioned T over here in the customer, and we are giving the answer as match position. So normally when alias name is not given, it will give the answer as no column name. But when you give an alias name over here, it will give the character index as 4. So T is over here. T's position is coming as 4 over here. You can count 1, 2, 3, and 4 over here. In the similar manner, we can give ASCII codes over here. I'll give an ASCII for T over here when I execute this query. Now ASCII code are American standards. So every particular text has a code. From small a to z, we have 65 to 90. And for big one, we have 97 to 122, if I'm not wrong. If you execute for the particular part for T, it will return 116, 97 to 122. T is coming at 116 number. So these are the adaptation that are normally used in higher programming languages to get the text out of a number. In the same manner, I have len function over here. Now in the len function, when I leave length over here, len for hello, you can see 6 is coming. Even if I increase space over here, it will return the 6 as a value. So you can say over here, select len from hello as length of text. So when you execute this query, this is how it will come up. Same way we have a concatenate function. Concatenate will concatenate the text into the particular values. So I have select concatenate Ram space Sharma. When I execute this query, we'll get a concatenation over here. In the same manner, we have left function over here. When I write the left function, it will start counting from the left hand side. 1, 2, 3, 4, 5. When I execute the query, now left will not count the position. It will count the number of text. From the left hand side, if you put 5, it will give you the 5 values from the left hand side. So when I execute this query, it will give me the 5 values from the left hand side. Same way I can convert the entire text into lowercase by using the lower function. So you can see SQL session has been mentioned as uppercase inside this thing. It will convert it into lowercase over here. Similar manner, I have a reverse string over here. Reverse will give the answer in reverse format. So over here, I have put a string over here. Hi, I am your trainer. When I execute the query inside it, it will give you in a reverse format. Entire text has been given in a reverse mirror effect has come up. Right is opposite to left. Right will give you values from the right hand side, 4 values from the right hand side. So when you execute the right statement, it will give you 4 values from the right hand side. In the similar manner, I have substring function also over here. So substring is something that is used to extract text from the middle of the text. You see my email ID is mentioned. I'm saying starting position is 4. So it will go 1, 2, 3, 4. And then I'm saying give me 10 text after that, 10 alphabet or 10 values after that. It will execute and give me the answer accordingly. You can see the answer will have 1, 2, 3, 4, 5, 6, 7, okay, 8, 9, and 10th is the A. So that is how substring works over here. After the substring, you can see over here, again, we are doing a substring over here. From first position, 3 values. So SQL will be returned. Trim is a function that is used to remove empty spaces from the starting and ending of the text. So I'll run trim. It will remove the empty spaces from the starting and ending of the text. In the similar manner, we have upper function. Upper function will return the entire string into uppercase. Over here, I've given a condition. I'm putting the email ID. I'm saying character index. I'm passing the character index of @ from dhruv777@gmail.com. When I run this query, I'll get the position of @ as 10. You can count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is giving the position of @ in the string. Now in the below query, I'm doing a uppercase over here. So upper is saying whatever will come inside these text will be in uppercase. Left will extract the value from the left hand side. Till what? Till the position of @. So character index will return the @ position. So if you run character index over here, it will return this as 10 over here. So character index is actually returning 10 if you see over here. 10 will be returned by the inner query. I want till @, not @. That's the reason I've done a -1 over here. So -1 will return 9 over here. Upper will take it as 9 numbers and it will print you 1, 2, 3, 4, 5, 6, 7, 8, 9. So you'll get the values till Dhruv 777. So that is how you can mix and match your string function and get values according to your requirement. This was something that was giving us the text before @. If the position of @ not known, then you can use character index over here in combination with left. That is how this thing works. These are some string functions that we have done over here. Now over here, we will see how to create aggregate functions. For aggregate functions, we have to add database onto our SQL Server. You can go to your browser and you can search for databases. So I'll search for a .back file for the databases. So I'll search for AdventureWorks.bak, that is the format, download. When you search for this thing, you will get the first link over here. This is the Microsoft link. Open this one only. So I'll add this AdventureWorks database to your particular Microsoft. You can see multiple databases are coming up over here. You have to select any one from this side. I'll select a database for 2022. When you click on it, it will start downloading that database. Okay, you can see the database is getting downloaded. Let it download once. Now, once this database has been downloaded, what I'll do over here is I will go to my database option. So you can see databases are coming at the left hand side, right? Right click on the database. You will see over here, there's an option of restore database. We'll select restore database over here. In the restore database, I'll go to device and I'll click on this three dots. We'll click on add over here. You can see there is some path that has opened up. Now over here, I'll copy the path that is there at the top of the screen and I'll pass it, like I'll open it on my notepad. This is very important that you copy that thing and open it over here. So I'll paste this path over here. This is the path. C program files Microsoft SQL Server. So I'll reduce the size of this path. I'll open my file folder where I have the downloads. So this is the AdventureWorks that I've downloaded. We'll copy the path that, like, we'll follow the same path that is mentioned. It is mentioned as C. After that, it is mentioned as, so every particular PC will have its own path. So you follow your own. Program files, Microsoft SQL Server. Go to MS SQL Server over here. Select MS SQL and go to backup over here. In the backup, paste this particular database. You can see this database has been pasted. You have to download the 2017 database. I already had the 2017, so I've downloaded 2022. Now, after this, I'll minimize this thing and I'll refresh this path. You can see 2022 database is showing up over here. I will click on again over here. You can see this database is showing up. When I click on OK, this database has been added successfully. You can check at the bottom, it is showing AdventureWorks 2022. So on the existing database that we have now the AdventureWorks 2017 also and 2022. Now you can use this database. I'm using AdventureWorks 2017. I'll execute this query. There's a table called sales.sales territory. When I execute this table, I'll get the territory ID, name, country, region code, sales YTD, all these details over here. With this pre-populated table, we will see aggregated functions. The first one that we have over here is select max of sales YTD, and the name is max value from sales.sales directory. When I execute this query, I'll get the max value over here. So we are getting select max of sales YTD as max value from sales.sales directory. You can see max value is coming up over here. In the similar manner, we can do it for min value also. Max will get the maximum from the particular data, min will get the minimum over here. Because you have given the alias as min value, it will give you as the min value over here. In the similar manner, we have a count star over here. Count will count the number of rows from the sales.sales directory. When I execute this statement, I'll get the number of rows as 10 over here. There is a top 5 over here. Now, as the name suggests, top 5 will give you only the 5 values from the top of your table. No ranking or number will be considered. The order that you are given over here is sales YTD, name, country, region code. When I execute this particular statement, you'll get the top 5 values. You can see 1, 2, 3, 4, 5. In the similar manner, we have a top 5 over here, which is taking name as an input first. So because the order is name, now the name will come first, then sales YTD, then country region code. So this is your max, min, count, top over here. These are some aggregate functions. Now going on further, I'm doing a count of country region code over here. And I'm saying that the alias name will be country total from sales.sales directory. When I execute this statement, it is returning 10 as an answer. It is counting the repetition also. Country region code has repetitions in it. If you want to see, you can do a select star from the entire table. You will see country region code is repeating and 10 is coming, which means for sure it is repeating. How to avoid the repetition? For this, distinct comes into picture. So if you see over here, distinct is coming up. Distinct country region code will give the distinct. So now this is not giving you a distinct count. It will give you the distinct values first. So when I do a distinct of country region code, it will give me all the values without any repetition. And I've given the alias name as country region code. So it is coming in that manner. So I've done a distinct first. After doing a distinct over here, I'll do a distinct count. So distinct count is simple over here. You have to apply the count over the distinct count. So when you execute this particular query, it will give me the distinct count as 6 over here. So that is how distinct count works. Now, once you are clear with the distinct count, we'll go to sum. Sum is a basic function that is used to sum the values. So it will give the sum of sales YTD. We have an average function which will give you the average of sales YTD over here. Basic functions that we are seeing on the aggregated part over here. Now, once we are clear with this part, we have an entire column coming up. Now, this is a statement where I'm saying that I want everything at once. Max of sales YTD as max YTD, min of sales YTD as min YTD, count star for total number of columns, count country region code as country count, distinct country region code as distinct country count. Then we have sum sales YTD, average for average sales from sales.sales territory. When I execute this statement at once, you can see all the columns are coming, which are returning us the value over here. So max YTD, min YTD, total columns 10, country count 10. Then we have country to distinct country count, sum YTD, and average sales over here. Once you have done this thing, the next part that we have over here is group by function. Aggregate functions and group by functions can be combined together. So we'll see an application of this. I'm saying select country region code and sum sales YTD. Sum is an aggregate function. And I'm saying from sales.sales territory, group by country region code. So I'll get country region code wise sum sales YTD over here. No repetitions will come up because you have done a group by on the basis of country region code. So country region code wise, I'm getting the total over here. This is the group by application. Once you are clear with this thing, the next part that we have over here is select country region code, name, sum sales YTD as total from sales. So this is something that is grouping two values over here. Group by country region code and name. So it will create all the possible iterations of this and give you the values accordingly. So country region code and name wise, we have done this iteration. Now, once you are clear with this thing on the group by clause, we'll go to the next part. The next thing that we have is group by with having clause. See, somewhere or the other, where clause cannot be used over here. I'll tell you why. Because where clause is something that is used with the combination of grouped values. If I say where is used without aggregate functions. Wherever aggregate functions will come up, having clause is used. If you see over here, I'm saying select country region code, name, sum sales YTD as total from sales.sales territory, group by country region code and name, having sum sales YTD greater than this value. Having is used because aggregate function is over here. When I execute this thing, you'll get the value over here. So you can see lesser values are coming now because I've applied this condition. So having clause are used with aggregate functions. Wherever there is aggregate function, you cannot use where clause. Now over here, if you see, I'm doing a basic query. Inner query is saying that give me the sales YTD from sales.sales directory where territory ID is 1. So when I execute, this is the sales YTD coming up. If you do a select star, territory ID 1's detail is 7887. This is the sales YTD. It is saying that, so if you see this particular condition, what is it saying? Inner query is saying, give me the sales YTD of territory ID 1 that has been returned. Outer query is saying that give me the territory ID from sales.sales territory whose sales YTD is greater than 7887. Now over here, 7887, the value that is greater than that is 105 this thing, and the territory ID is 4. When I execute this statement, it will give you the value that is greater than territory ID 1, that is 4. So this is a combination of subquery that we have used over here. Innermost query will return the answer first, then outermost query will run. Once I have done this thing, we'll go to the next part. Up over here, you will see where has been used and there is a aggregate function also. Now there is a clause over here. Aggregate function has been used inside your particular subquery. So select max of sales YTD is giving you the maximum value. That is 105110853. This is of territory ID 4. We remember that. It is saying give me the name from sales.territory. So name, if you want the territory ID, you can get the territory ID also over here. When I execute this statement, it will give me the name and the territory ID of the value that has the maximum value over here. So this is the combination over here. Now the next statement that we have over here is select country region code from sales.sales territory where name is equal to Northeast. So name has been returned over here, US. US is the country region code where name is equal to Northeast. Now outer query is saying give me the country region code name from sales territory wherever this country region code is there. So US will be at multiple places. You will get multiple answers and we are getting all the names over here. If you require anything else, you can add it over here. I need the territory ID also so that I can track these transactions. This is the transactions territory ID. So this is how you use multiple subqueries together. We will have a dedicated topic to this, but I just wanted to play around with this data set.